Vice President, Consultancy, RE Sustainability Limited, Hyderabad, previously known as Ramki Invaro Engineers Limited, Hyderabad, and Dr. Indranil Chaturaj, Director, NML, Jamshedpur. All speakers of this particular event, and all officials from our CSR headquarters, Dr. P. Ashokan, our senior chief scientist of this particular institute, CSR MPRI, and all my scientist colleagues and ladies and gentlemen, we are fortunate to have this particular event here. And I'll first of all, I'll request Dr. Ashokan sir to give his welcome address and introduction of this particular event. Thank you so much.
सबको नमस्कार. Honorable Chief Guest of today event, Shri Suresh Tripathi, the Senior Consultant, Navakrit, and former Senior General Manager, Aditya Pirlaguru. Our guest of honor today, as well as the keynote speaker, Dr. P. Chakradhar, the Vice President, Consultancy, Re-Sustainability Limited. In fact, it was earlier the Ramki Engineers Service, Hyderabad. Esteemed our Dynamic Director, Dr. Avanish Kumar Srivastava, and distinguished Dr. Anandavalli, the Director, Structural Engineering Research Center, Chennai, and the Team Director of Civil Engineering Infrastructure Team. Our special invitee and guest of honor, Dr. Indranil Chaturaj, Director, NML, Jamshedpur. We have with us today the technology presenters, Dr. Sinha, Dr. Rohit, Dr. Lakshmi Kandan, and Dr. Amble. So today, Dr. Manish Mutkal is moderating this program, and Dr. Tipthi Mishra also with us. In addition to that, we have my friends and staff who are supporting in organizing this event. Dr. Rajanish Gupta and Dr. Devendra Singh, Senior Principal Scientist from headquarters, they are organizing this event, and we welcome all of them, as well as the main organizers of officials from Ministry of Science and Technology and Earth Science. We welcome you all. And there are many delegates participating remotely from all over the India, that include Mr. VP Singh, Director, MSME, Yamunanagar Plywood Industry Cluster, and many directors from MSME from Haryana, Madhya Pradesh, Delhi, and senior officials and CV of industries, major industry, MSME, and startup industry are here with us today. Many professional builders, architect, designer, construction agencies are also with us today. And there are many academicians and researchers are watching us, and the student, teachers, and scholars from many school, universities, and colleges are also watching us today and participating in this very important event. So on behalf of the director, CSIR Ampri Popal, and the iConnect event, I, Dr. Ashokan Papu, Chief Scientist and Coordinator of this event, very warmly welcome you all for this important industry meet, that is iConnect 42, to deliberate on the topic alternative building materials and structures using silica-rich waste materials. I believe today your participation, your learning and gaining and sharing of your knowledge and addressing to the gathering has a very significant role in the R&D transformation to increase the nation economy and enhance the employment, improve the livelihood of the people of rural, as well as to safeguard and sustain our balanced ecosystem. And thus, I am sure with all our intervention, we will be able to contribute in achieving national goal on Atmanirbhar Bharat. With this, once again, I warmly welcome our guest speakers, our directors, technology presenters, and all the participants and delegates participating at different part of the country in this industry meet. And I trust you all will enjoy this event for the mutual benefit in the interest of the growth of the nation. Namaskar.
So once again, I would like to welcome Dr. N. Anandavali, Director CSR SERC Chennai also for opening remark. And now I request my Director of CSR EMPRI, Dr. Avnish Kumar Srivastava sir, to give introductory address.
Namaskar, good afternoon to all of you, and welcome to this industry meet 2022. In short, we call it iConnect. It's scheduled during 5th to 15th July, and today is the second day of that is 7th July of this program, and the CIE theme, that is civil infrastructure engineering, on in particular on waste to wealth. So CSIR Advanced Materials and Process Research Institute, in short we call MP, CSIR MP Bhopal, is organizing this mega series of iconic 75 Industry Connect, iConnect events on waste to wealth under this CI theme, that is civil infrastructure and engineering, to showcase the achievements in various SNT areas from 5th to 15th July. This event would be a befitting tribute to the pride and prestige associated with celebrating the 75 years of Indian independence. And the objective of this CSR Amplis, this organization of event on waste to wealth under the CI theme, is to foster a strong Atmanirbhar Bharat, self-reliant India, by providing indigenous technology on waste to wealth, by forging a partnership with industries, and to provide a common platform for industries, entrepreneurs, stakeholders, government leaders, startups, academic scholars to maximize the benefit of solid waste recycling technologies, in particular having TRL, that is technology readiness level, more than 6. In this connection, today, as I said, is our second technological session on the theme of alternative building materials and structures using silica-rich waste. Dr. Anandavalli, Director, CSIR Structural Engineering Research Center, Chennai, and the Team Director of CIE theme, that is Civil Infrastructure and Engineering of CSIR, is here, and she will be giving the opening remark. The plenary talk will be given by Shri Suresh Sri Tripathi ji, consultant Novacret and former senior GM Aditya Birla Group, in the area of opportunities for the construction industry for the uses of C&D, that is construction and demolition, and other inorganic waste. Today our keynote speaker is Dr. B. Chakradhar at Consultancy Division, Sustainability Solutions Private Limited, Hyderabad, and he will discuss the area of solid waste management. The program session chair is our Dr. Indranil Chaturajee, the Director, CSIR National Metallurgical Laboratory, Jamshedpur, and he is also the Theme Director of 4M, that is Mining, Minerals, Metals, and Materials of CSIR. So various technological presentations in the area of alternative building materials will be presented by scientists of CSIR labs, including Dr. S.M. Mustaqim from IMT, Institute of Minerals and Materials Technology, Bhubaneswar, Dr. A.K. Sinha from Central Road Research Institute, Delhi, Mr. Rohit Mishram from National Metallurgical Laboratory, Jamshedpur, Dr. K.N. Lakshmi Kandan, and Dr. P.S. Ambly from SERC Chennai. I also see on the screen Of course, conferrer Dr. Manish Mudgal, then Dr. Muhammad Akram Khan, Dr. Deepti Mishra, Dr. Sarika Verma. I can see this on screen, so it's good that I acknowledge them for their kind presence. And the session is going to be a significant pathway for transforming CSAR technologies and creating a new platform for connecting industries, entrepreneurs, and startups for a collaborative program and long-term association for mutual benefits. I really thank to the main coordinator of this program, Dr. P. Ashokan, who is taking so much interest and untiring efforts from all directions to coordinate this program between the dates 5th to 15 July. And that is how we are able to coordinate with so many people and to bring them at single platform for the benefit of the nation by utilizing the waste and converting waste to wealth. It's a very good concept. And waste, although there are several dialogues that waste is no more waste and so on, but waste is waste. Let us accept the fact. But we are here to utilize waste and convert it into the useful products. So that is the motto of the R&D in this direction. And we welcome all the industries and stakeholders who are directly or indirectly connected to this program. So with this brief note, once again, on behalf of CSIR AMPLI and also on my personal behalf, I welcome all dignitaries to this very important program of iConnect under the theme of civil, infrastructure and engineering with an emphasis on waste to wealth. Thank you all. Namaskar.
Thank you, sir. Thank you. Thanks for blessing us with your words. Now I'll request Dr. N. Anandavali, the Director SCRC, CSR SCRC Chennai, Madam, to give opening remark.
Thank you. Shri Suresh Tripathi, Senior Consultant Navocrete, Dr. P. Chakradhar, Vice President Consultancy Sustainability Limited, Dr. Avinash Kumar Srivatsava, Director CSR AMPRI, and Dr. Indranil Chaturaj, Director CSR NML, Dr. Ashokan Papu, Chief Scientist, AMPRI, and Nodal Scientist CIE team on Waste to Wealth, Dr. Manish Mudgal, Dr. Deepti Mishra, CSIR AMPRI, scientists from Technology Management Directorate CSIR, speakers, scientists, academicians, researchers, industry partners, ladies and gentlemen. A good afternoon to you all. I'm happy and glad to be present in this session on alternative building materials and structures using silica-rich wastes of the iConnect event on waste to wealth under the Civil Infrastructure and Engineering team. On behalf of the CIE team, I welcome you all to this event. So, as we all know, concrete is the dominant material used in the construction industry, from simple family houses to architecturally innovative skyscrapers. Increasing use of cement in the construction industry is causing an alarming increase in CO2 emission. So, a study like 0.8 kg of CO2 is emanated in the atmosphere during the production of 1 kg of cement clinker. Also, it amounts to about 6 to 7% of the worldwide CO2 emission, which is a serious environmental threat. And it can be reduced by addition of supplementary cementitious materials. Many efforts have been made to diminish excessive utilization of cement in the concrete industry to minimize the greenhouse gas emissions. And also towards technological breakthrough of reducing cement as a standalone binder in concrete, significant efforts are being made by engineers and scientists. The common methods to modify the main binder are incorporation of supplementary cementitious materials as partial replacement to cement, development of alternative binders that entirely replace cement. So the commonly used supplementary cementitious material like ground granulated blast furnace slag GGBS, metakaolin, and fly ash have been successfully used to replace cement partially or completely. These materials exhibit pozzolanic activity, and the compounds making up these materials react with hydration products of cement, resulting in the development of surplus calcium silicate hydrate gel, CSH. This behavior improves the overall performance of the cementitious composites. The use of silica-rich materials is another potential solution to partially replace cement. Recent studies also reveal that waste glass powder rich in silica can be used as cement replacement too. Silica fines such as microsilica, fumed silica, silica flour, and nanosilica are primarily composed of high content of silica and with extremely small particle sizes. So industrial activities around the world generate a wide variety of silica-rich byproducts that have become a major environmental concern. And also it is very crucial to identify suitable waste management techniques to reduce their impact. One of that is utilizing that as supplementary cementitious materials for enhancing the performance of the cement concrete. And also there is a number of recent studies, considerable studies on incorporating these silica-rich materials as both precursors and activators, including fly ash, blast furnace slag, silica fume, and waste glass. Also, geopolymer have been recognized as a viable replacement to ordinary Portland cement, providing a cleaner solution, and also it can significantly reduce greenhouse gas emission, as well as it accomplishes effective waste recycling. On the other hand, there is urgent need to find novel approaches to reuse the massive quantity of waste materials resulting from construction and demolition practices. Natural sources such as clay and kaolinic, byproducts such as fly ash and ground granulated blast furnace have been used in geopolymer concrete, and recently construction and demolition waste have been identified as raw material for geopolymers due to its availability and high content of silica and alumina. And silica fume, as we all know, is being used as a mineral admixture in concrete because of the fineness of the particle, which can fill better the spaces between the components of concrete mix. The concrete such as high strength, high performance concrete, ultra high performance concrete, which has compressive strengths ranging about 150 or so, and the high strength polymer concrete are obtained by adding silica fume of appropriate proportions in the mix. So in this technical session, we'll be hearing more on this. I would like to quote a Tirukural, Epporul ettanmayadayinum apporul meipporul kanbadu arivathu, which means that analyzing the information, understanding the meaning, and accepting the fact will help one to gain profound knowledge. And true knowledge is the ability to understand the truth behind people, things, and events. That is basically research. Thank you.
Thank you so much, ma'am, for your elaborated technical guidance in this particular field of waste to material development. Now I'll invite Mr. Suresh C. Tripathi, Senior Consultant, Novacrete, and former Senior GM, Aditya Birla Group, for plenary talk. I'll just read his short CV. Mr. Suresh Chandra Tripathi, he is a senior consultant, Novacrete, Noida, and former senior GM of Aditya Birla Group. Mr. Tripathi has completed his BE in civil engineering from University of Mysore in 1985 and PG diploma in business administration from Management Promotional Institute, New Delhi in 1987. He worked as Senior General Manager, Utkal Alumina International Limited, Aditya Birla Group, Associated Vice President in Gen Infra Projects Limited, Head Technology, SP Precast Solution Private Limited, Vice President Technical, Supertech Limited, and Head of Precast Business, Patil Groups. currently working as Senior Consultant, Novacrete India, and Executive Director, Earth Enviro Private Limited. When about him, I'll tell you he has a 36 years of rich experience in the projects construction in the field of construction and evaluation of new technologies and innovation in precast technology manufacturing, setting up new plants, structural health monitoring, and related business development. He has a vast experience in research, expertise in execution of greenfield, brownfield projects, and expert in construction technology and with special knowledge of structural health monitoring. A strategic planner with expertise in planning, execution, and spearheading green field projects involving contract and site administration and resource planning. He has an excellent relationship management, analytical, and negotiation skills in his career. So now I'll request him to give his plenary talk on opportunity for construction industries for use of CND and other inorganic waste. Sir, welcome. I welcome Dr. Suresh C. Tripathi for this particular talk.
First of all, namaste to everyone, and thank you very much for inviting me for this plenary talk on this opportunity for construction industries using the CND and other inorganic waste. I'm very thankful to Dr. Avnish, Dr. Manish, Dr. Ashokan, and I welcome all the dignitaries who are present here. And I present here the industry perspective of this. So I'll start with sharing my presentation. Is it visible?
Yes, sir, it's visible.
Okay. Now, to start with, is my screen visible, sir?
Yes, it is visible.
First scene.
It is opportunity for construction industry.
Right.
First slide. Yeah.
Yeah. Now, when we come to the first slide, I just wanted to present you with this one, that what is the current situation of CND waste. The official estimate says that around 175 million ton of CND waste is generated annually, and unofficial estimates is around 4 to 5 times more. And the country is having a recycling capacity of only less than 1%, around 65,000 ton per day. And I had got one statistic by that in 2017, 53 cities were expected to set up the recycling facilities. But out of that, up to 2021, around only 13 cities have these type of facilities. And one of the issues are that there is no uniformity among the cities to quantify and characterize the CND waste to know how, to what and how to segregate. And methods have not been updated to bring new technologies. CND waste has been very effectively used in Metro 4 phase, and that is one of the good practice which is which can be emulated. Now, what I find is in UP rural development.
So only first slide is visible now.
Okay. Sorry. Is it now okay?
We are seeing, sir.
You're able to see the second slide?
No, sir, only first slide we are seeing here.
Let me.
Is some technical issue. Please stop your unshare that presentation and again share it.
Okay.
And now it's slideshow mode में कर लें सर.
Now is it okay?
Yes. It's visible.
Okay. Sorry for the inconvenience. Now, so I was speaking that Delhi Metro has been very effectively using this C&D waste. Now UP, when we come to rural development, this one authority, they have used full depth reclamation in the rural roads. And then it is pioneering use of reuse of material. Now, price of urbanization, when you say that when you are urbanizing a city, then there's a lot of dismantling going on, redevelopment of cities, and repairs and other things are going on. And most of it is going into this one designated landfills. And the disposal of landfill is also having a what you call associated cost. And in the landfill, if you just see the transportation cost and the landfilling tipping, the land itself costs around in this one, what you call low and middle income countries, around $75, and or higher income one around 100 USD. Now, coming to the this one government initiative, what I find is that there are earlier there were a lot of hurdles in usage of C&D waste, and construction and Bureau of Indian Standard has allowed use of concrete from the recycled material from the C&D waste. But I still find that when it is coming to actual implementation, so the specifications do not allow use of these C&D waste, and there is a lot of awareness which has to be created to all the stakeholders for this use of this C&D waste. Now, and Swachh Bharat Abhiyan has also recognized C&D waste, and in the Swachh Sarvekshan, and cities, and they have already specified that C&D waste, how the C&D waste will be this one collected and notified, and cities have. And another thing is that NHAI has also mandated use of new technologies of cement treated base by around 10% length in the 2nd June 2022 circular. So on government level, a lot of initiatives are being taken, and this initiative is also on the same line of AMPRI. Now, coming to the complete perspective of this industrial waste, so their industrial waste can be managed in three in this integrated management hierarchy, that is reduce, reuse, recycle, compost, incinerate, and landfill. The last three ones are the one which should be termed last. And first our thing, and reducing, having the lowest this one, and landfill is having the highest, this one, negative to the environment. And the most important contributor to the waste minimizations are reduce, reuse, recycle. And this is called 3R strategies, which in construction industry should be made mandatory. Skip. Now, when you go into this one typical construction companies waste compositions, you will find that there is a 60% of the potentially reusable recyclable material, which is inert material, and non-inert waste is around 35%, and only 5% is normally required to be disposed to the landfill. Inert waste in this context specifically refers to the physical to material or item that is not undergoing any significant physical, chemical, or biological transformation, but not including any hazardous or green material. Although 95% of CE and DW waste is potentially recyclable use, but most of it currently goes in landfill, especially the high quality inert waste, which is more than half of its generated waste, indicates a great potential of reuse. And this is to be understood and would eventually not only reduce the cost of C&W management, but it also contributes to the construction company revenue and increased reputation. Now, opportunity to practice based on the reduce strategy. If your first is reducing, the best ways to reduce waste is not to produce it, and therefore it is ideally to start in the design stage itself. And the case history of many projects infers that improper design has led to a lot of waste generation, and there is excessive cutoff. The design stage usually requires comprehensive, conscious, and innovative approach. And for this, one of the most common and effective method of use is adopting building integrated model technology, that is BIM technologies. And next one is use of prefabricated material or precast technology. So based on my experience, especially since I've been into precast field from last 10 years, we have been adopting BIM from the design stage itself. The BIM technologies comprise of the digital modeling of the building, and it contains all technicality, that is geometric, quantity, character, and material functions like scheduling, cost, and resources. So if we mandate to the construction industry that you get into BIM technologies, so that will significantly reduce our waste. And we will be able to also, these days for the steel also, we are getting cut steel available by the steel manufacturers. So that also reduces the wastage in the steel. Then with this, there is a study which has told that we can, by use of BIM technologies, we can reduce the waste to around 15%. Now, taking into consideration the prefab and precast technologies for a construction industry, adopting prefabricated material of construction, which is known as IBS. So in this involves the material which are manufactured off-site, and compared to the convention, the use of raw material for on-site component production and use of the fabrication and when you fabricate in the factories. So there is a considerable reduction in the losses. I have been managing a lot of precast factories. There absolutely we don't allow any wastage. We also recycle all the waste which is coming out, aggregate, we crush it up and then reuse it. We use up to around 1% of all the and reuse into the concrete. So when you go see into prefabricated material, there are precast buildings, precast facades, staircases, partition, bathroom pods, balconies, and PT slabs, hollow core. All these are the components and the other thing of building materials. So and now government also is have mandated that around 15% of especially in road also the precast technology should be propagated. The quantitative advantage of using prefabricated material has been studied, and it has been estimated that it replaces around 70% of the finishing work on site and reduces even the associated with timber is around 74 to 87%, and associated with concrete is around 50%. So comparison between conventional, mixed, and IBS construction, we find that all the construction which were there on site produces 1.5 times more waste than mixed construction and 3 times more than in IBS. Then practice of based on reuse strategy. So when you are using it, that is, you are using the, you are extending the, sorry. Reuse initiative aims to extend the material life cycle and repeat use for the purpose of benefiting the opportunity to use the secondary purposes of this one. The crushed concrete can be used as sub-base of the road construction, and aggregates for the concrete or asphalt as a drainage material. So it has been seen that around 1 to 3% recycled concrete in the foundation, a retaining wall, reinforced concrete beam, ground level, and this one, and pile cap. Around 15% can be applied in haunch and drainage layer, 50% of the rock fill and the filter layer, and 15% of the subbase, and 20% of the block paving. From practice, it can be assumed that around 80% of the concrete waste generated can be reused or recycled, then to be reused for the purpose. Now, I also these days we have brought one technology that is for the innovative use in which we stabilize the soil or waste or material which is silica having more silica in that. So we stabilize that using Novocrete. Novocrete is also a additive which is used in ordinary cement. This is a non-toxic, non-detrimental, environment-friendly material, and it is innovative way of making roads, yards, earth stands, and stabilizing using existing soil or without excavation and disposal, and soil replacement, recycle aggregate, or even without asphalt or concrete. It utilize and this technology is very much useful for road, rail, yard, or hot stand area construction. So this is basically cement-based, cement-treated base technology which uses soil, which stabilizes soil, and in this, you know, FDR is also there. That is full depth reclamation. Now in UP, a lot of rural roads are being upgraded, and the same material which is there in road is being recycled and used there itself. So no further additional material is brought from outside and being used. UP has been pioneer in adopting that technology, and this is to be scaled up and taken to all over India. And again, this is Novocrete. It is mixed with soil, and you can just see when you compare the thing, when in the normal conventional, you have to go minimum around 80 centimeter depth, and this with Novocrete around 1/3, you can do the reclaiming. Now, on the basis of reuse strategy, the gypsum drywalls which are coming up, that also has a lot of alternative uses. This can be recycled, and it can be used for this one effectively for the compost additive, which have low levels of nutrition of sulfur and calcium. Gypsum increases level of calcium in compost and then helps in utilizing the acidity that might be present in the compost and mixture. So, and using gypsum as an additive are higher need of effective monitoring. Actually, all these technologies which are being used, like even the soils, this Novocrete or this gypsum, and all this requires a lot of knowledge about mixing of the how the soil is behaving, and geotechnical knowledge, and here the how the material will be reacting. So this also paves way for the new generation scientists who will be used and who can do research and reduce the quantity of usage and effectively use these technologies. And recycle is a popular one, which I don't want to size much here, because our main theme is usage. So timber recycling, metal has been recycled. So for me, I just want to say that this initiative of AMPRI is very good, and we'll be listening to others. And I hope that my brief, of construction industry, my experience of the construction industry and utilizing which we are doing, that will be helpful for the others. Thank you very much. If any question is there, I can answer that.
Yeah, I will have some.
Thanks, Tripathi sir, for giving elaborated talk on this particular opportunities for construction industries for use of CND and other inorganic waste.
I have some questions.
Yeah,
Maybe
Dr.
if,
Ashokan
you
sir
permit,
is having some questions.
yeah,
You can
yeah.
unshare your presentation, sir.
That's fine. Yeah, thank you very much, sir. Thank you very much for your very, very exciting information about the CNT waste. Actually, in fact, CNT waste is going to be a future challenge to the country like India. And it is in fact a great learning for us. Actually, sir, when we were estimating the quantity, almost 175 million tons of CNT waste generated in India. When we consider even the total waste itself, about 1 billion tons, and the organic waste maybe of about 50%, and the inorganic waste remaining 50%. Even the municipal solid waste itself is look like lower than the construction and demolition waste in the country.
Very true.
Do we have any source like state-wise or sector-wise the construction and demolition waste generated in different part of the country? It's like a recorded or validated reference record. Is it possible to have that inputs? Actually, you know that in European Union or other countries, it's again a challenge. I mean, particularly in the Europe, they were facing a lot of challenges for the last 10 years, and slowly now it's coming to converting into the aggregate and the other building product. But now in India, only the undulated areas people keep dumping it, and still in converting into aggregate to set up a very big commercial plant, yet not yet reached. Still, but it is things are changing now. I'm sure maybe in a couple of years we can see many industries in this area. Just looking for, maybe I will separately come to you or meet you. Want to have some reference record for this quantitative information on this particular waste. That's it.
So many consultants have done the studies to know the
Thank you, Dr. Manish. Maybe I will contact
enterprise value
separately.
and
And we will be in
of
touch
this
with you
type of
since there is
business.
limited time.
And
We can request our next guest speaker.
yeah, please.
Secretary.
Because Ramki has been one of the pioneers in doing this CND base. So I think he will be the right person to answer this question. And since I've been on the user front, so I've been using, so I see the potential of usage of it to the perspective like in precast and other things. There are a lot of things where we have better control in the concrete. So yes, Dr. Chakradhar, I think it will be very informative to hear from you, sir.
Basically, there are more than 10 to 15 plants physically working presently under Ramki all over the country. So things are going. Of course, I was asked to present for some solid waste management, not on CND, but I have very specialized information on CND also from our company. Plenty of plants are presently working in Hyderabad, in Delhi, in Chennai. Many places we have already established CND plants and preparing all these what Tripathi Saab has made. Excellent presentation. I really appreciate that. If you have any information from our side, definitely we can provide you. I'll Ashok. Nice. Right. Thank you, sir.
Thank you. Thank you very much, sir.
Thank you so much, sir. So thanks to Tripathi sir for giving this elaborated talk on this CND waste. Now I'll invite Dr. B. Chakradhar, sir, he is a Vice President of Consultancy, RE Sustainability Limited, Hyderabad. First of all, I'll go through his CV. He is a well-known personality in EMPRI Bhopal, previously known as RRL. Uh, Dr. Chakradhar sir is Vice President of Consultancy RE Sustainability Limited, Hyderabad, previously known as Ramki Enviro Services Limited. Sir has done his BTech and MTech in Chemical Engineering from Osmania University in 1980, and he has done his PhD in Chemical Engineering from LIT Nagpur in 1995. His specialization was in environmental engineering, and Sir has joined NIRI Nagpur in 1982 and worked there up to 1995, and 95 to 2007 Dr. Chakradhar was means he has worked in regional research laboratory. Now it is known as CSR EMPRI. So at that moment of time, he was means known as a very dynamic personality in this particular institute. He has established environmental group and completed more than 60 projects in all parts of India. I am fortunate to read his CV. Myself, Dr. Manish Mudgal, I have done my PhD under Sir's guidance only. And we three here sitting here, Dr. Akram Khan, Dr. Dipti Mishra, and Manish Mudgal, we have joined in his tenure only, under his guidance only. We have learned a lot in this environmental group. Presently, he is heading consultancy division of RE Sustainability Solution Private Limited, and he has a vast experience of 41 years. He has guided 7 PhD students and registered guide for RGPV Bhopal and Barkatullah University. He has guided. He is also guide for Jawaharlal Nehru Engineering and Technology Institute, Hyderabad, Telangana. He has guided more than 90 students for MTech studies. Expert committee members for thematic expert group of on prevention and abatement of control of pollution for environmental research, National River Conservation and Climate Change in Ministry of Environment, Forest and Conservation, New Delhi. He is member of CFO committee of AP Pollution Control Board. He is expert member of hazardous waste contaminated site monitoring, bioremediation and control of Ministry of Environment and Forest, member of Board of Studies in Technology under Faculty of Technology, Osmania University, Hyderabad, and he has his specialized areas are environmental impact assessment, risk assessment, disaster management plan, ETP and STP designing, water resource management, DPR for hazardous waste, municipal solid waste, and biomedical waste. He has a number of publications in national and international journals. He has completed projects. In NIRI, he has completed 72 projects, at RRL 74 projects, and again he has joined NIRI, where he has completed 3 projects, and now in RE division, means RE, this present institute, he has completed more than 200 projects. So he is a stalwart in this particular environment engineering faculty, and he is well known personality in India in environmental engineering. So I welcome sir for your keynote address.
Thank you, Dr. Manish. Of course, I am also grateful to Dr. Ashokan, in fact. In addition, Avinash Srivastava, Director of the Institute, AMPRI. I also have credibility for Madam Anandavalli, CSIR, SCRC, then Tripathi Saab and all other colleagues. In fact, I am so happy to see you all here. I am a former partner of your own institute, as you are just mentioned. Definitely to see, very, very happy all you three are inviting me and asking for certain technical presentations. I really bless you all. Basically, you are also junior colleagues who grown, and I have seen you grown to this extent. My blessings are always with you all. Well, I'll give the presentation. Definitely, I'll keep crisp. The time must be running out. I'll give a short presentation on solid waste management and opportunities. Please just, I'll share the things for you. Yeah, hope, is it on the screen? Manish?
Sir, it is needed. Yes, it is visible, but only
It's visible,
slide
no?
mode, you just convert into slide mode.
Okay, right. This is the, I hope, is it moving also?
It's moving, sir, but two slides are seeing. Slide
I
mode,
want to
if you can do
just,
it.
is it move? It is a moving mode only, isn't it?
Yeah.
Yeah. Now, uh, well, the topic solid waste management opportunities in civil infrastructure and engineer and policy and framework. Of course, this is one of the very, very, the important level of thing I can mention. If you see the photograph of what the pictures, I just kept it. All these activities really badly needed a civil engineering infrastructure as well as engineers. Without them, absolutely we cannot further move at all. So I just kept that, to give a glimpse of solid waste, what is happening in our country today, around 56 million tons of MSW expected to generate. And you see hardly subsequent slides, you see around, out of this only 36% of the treatment is going on. Around 70 or 65% is yet to be done. And there are certain policy guidelines. As you are all aware, although the government has laid out specific regulations for solid waste management, it is commenced in 2000 and subsequently recently amended 5 years back, 2016. But the compliance is minimal. Of course, this is very, very toughest topic in the country in waste management. When you compare with your hazardous waste, you compare it to your biomedical waste, compare to your recycling. Municipal solid waste is one of the toughest because it mainly handles by the municipal corporations of each part of this country. Now, if you see the statistics, as I just mentioned, our country generates around 1.5 lakh tons per day. That is almost, collection part, definitely we can say 98.4% collection. But treatment part, only 36%. So you can see the gap. And here itself, the importance of civil infrastructure and engineers really shows there is enormous, there is endless, because to cope up the backlog, the number of the infrastructure facilities needed in this country is unbelievable. So the topic which you people have selected is of top priority today by looking at only in one waste management of municipal solid waste. If you see that, if you see certain present scenarios, really, it's very, very alarming. And most of our colleagues who are present in this presentation, as well as general public, the level of infrastructure we need now to convert them is absolutely beyond talk. If you see this Ghaziapur dump site, what type of design, what type of civil engineering background, what type of infrastructure is unbelievable. So there are plenty of importance plays major role here, how exactly to handle such huge dump sites present in the country. If you see, this is again a dump site in Devnar, one of the oldest dump sites in Mumbai, near Mumbai, in fact. What is the real scenario happening? Nearly 1930 onwards, this dump site is active, and till even now also it is active. And recently, Ramki itself has taken up the project of waste to energy here, wants to establish around 8 megawatt power plant, for which, of course, Mumbai Corporation is working on it. If you see the Chennai, similar scenario, the quantities are enormous, 2,100 to 2,300 metric ton at Kodangur, 2,200 to 2,400 in Perundurai. So the level of lackness, civil infrastructure presently we are having, well, we have certain level of things. It's not that we are at zero level. We are definitely improved upon since last couple of decades on these aspects. As soon as in the year 2000, municipal guidelines have come, things have started initiating, and to some extent we reached. But the present scenario is, after looking at the scenarios, how exactly happening in the country, what is the need based today? If you see the Rewa level of Madhya Pradesh also, where we are again putting up a waste to energy plant here, which will be shortly initiated, and already activities are going on. The scenario. So imagine the importance of civil infrastructure and engineers, what you are all discussing. Plenty of scope is available, and endless requirements are needed in this country. Now, if you see the quantitative information around, if you assume around 100 grams on an average of our population in the country, around 47.45 million tons we will be generating in a year. Around, if you see 250 grams on an average in our country, it goes to around 120 millions. So the quantification is also one of the major constraint in our country. You have CPCB inventorization, you have World Bank inventorization, you have many organizations inventorizations wherein various type of tonnage will come. But ultimately, it's a huge that nobody can say on that. The challenges, what we are expecting, CPCB observes that most of the dump sites are unscientific. Of course, there is no need of declaring unscientific. It is 100%, it is unscientific. That's a basic rule. Recent development has come in 2016 with certain modifications. So landfill sites should preferably be used only depositing for inert. In fact, the new technologies, new opportunities today, earlier it was only a dump site. There was no other technology available. That means I am talking about a decade back or 2 decades back. But presently you have many opportunities have come. Public-private partnerships are entered into the picture and started entering into the new methodologies, which will be, if you see different challenges, how exactly in state policy strategies, then lack of coordination between UDD and ULB, state pollution control boards, leads to this sort of situation present. If you see the last line, as treated waste is only about 36% of the generation waste. So I just initially mentioned about 36% treatment. So rest of the things needs enormous infrastructure today, for which the designs, the brain back of all the civil engineers are badly needed. In fact, the recommendations what we generally comport, site selection is one of the major criteria. Fundamentally, state policy should support financial issues. Segregation of waste at source, of course, this is a fundamental notion from the beginning of the waste management rules, segregation at source. But still today, the achievement on this is a real question mark. because we have multi-layers of population, multi-layer of quality of people. So this segregation part is always one of the biggest challenges in our country. The state UDD should ensure safe disposal of legacy municipal solid waste, because you see plenty of dump sites are still existing, as I showed some of the photographs. So one has to convert all these dump sites to a treatment facilities. Then only we can really start of thinking. That's the basic reason that integrated municipal solid waste management concept has come, which basically covers recovery of recyclables, recovery of RDF, that is a refuse derived fuel, waste to energy concept, composting, bio-methanization, sanitary landfills. So these are all the concepts came today, and they are practiced in the country in many areas. It's not that we are not practicing, but we are practicing, but there is a lot of improvement needed in each and every level. In fact, technology selection is one of the criteria where characteristics of the waste quantity, land availability, location, funding, techno-commercial feasibilities are the basic parameters under technology selection criteria. If you see the collection and transportation, one of the biggest challenges in each aspect here, if you see the role of civil engineers and the infrastructure is enormous here. How exactly the commercial establishment, industrial markets takes, what is the transport mechanism, how exactly it will be segregated, how exactly it will be collected, street sweeping, mechanical sweeping, as well as local transfer stations is one of the major criteria in urbanized cities. Because you cannot directly take it to the long distance of dumping sites, wherein the local transfer stations will be the easiest way of collecting the local hazardous, local municipal solid waste and subsequently transfer it to the dump sites. So this is one of the collection and transportation mechanism. Then MSW facility itself, if you go for the MSW facilities, many facilities needs, this is the concept today presently we are adopting. The technology, the methodology adopted is what is shown here at various levels, and ultimately all the inerts which are ultimately segregated goes to the landfill. So that is a single layer landfill site. Then you have compost mechanism, you have RDF technology we will be making, then mass burn technology for energy. So ultimately rejects, as I mentioned. So today the RDF is one of the fuel. After preparing the RDF with a high calorific value, it is today used for waste to energy as well as cement industries. These technology selections, of course, these are all the technical things available. Old process flow sheet, as I just showed, I don't want to repeat it again. Now, if you see the Hyderabad, one of the key things what we are collecting, around 6,000 to 7,000 tons per day is treated in this location. One of the largest municipal solid waste facility in the country, I can surely say, because even in Delhi, even Mumbai, Chennai, Bangalore, all are up to level of 2,000 to 3,000 at multiple stages. But here in Hyderabad, it is only one place location and almost covering 6 to 7,000 tons. So this is the facility from on a bird's view, what we are making. And you see the past site, how exactly the previously the dump site, after Ramki has taken up this particular facility, if you see the bottom one, the sea change within a decade period, how exactly the uncontrolled level to controllable concept. So present scenario is the bottom one, which one is happening. And if you see the waste facility with all the structures, all the legacy dump site is totally covered with all your various technologies. And waste to energy plant is also presently working in Hyderabad. This is the Delhi plant, 24 megawatt, presently working, and in Hyderabad also similar thing is under operation. So this is waste to energy plant, of course. How exactly we convert our all the mass burn technology and all the inerts goes to the landfill. This is one of the methodologies. As I told, the opportunities of MSW is these. If you see this technology and the energy plant, what we have presently working in different places. Now the alternate uses of ash, whatever ash is generated, basically, this is not a new thing I should mention, but it is available. So there is an opportunity of the bottom waste which is coming from the power plants. Now this is the energy plant I showed you, just how exactly it is working and what type of majority of the MSW directly goes into this particular process. So reduces the land requirement as well as reduces the landfill area also. So these are all the different glimpses of Delhi waste energy plant, how exactly we operate. If you see Kadapa dumping site, that is the waste energy. If you see the before, what was the scenario, and after, presently, what is happening. So these are all the basic background of this is civil engineers and infrastructure of civil. So the key of all this success, whichever is what presently we are talking, definitely lies with the civil infrastructure as well as engineers. So the concept of CIE, what you people are making, really a masterpiece. As per my knowledge, since last so many years working in this company, more than 15 years I am in Ramki, and I seen the civil infrastructure, the importance of civil infrastructure in converting the waste management into the really usable things. This is the conclusion. I just thought I don't want to go into the details, but 100% collection, 100% processing, disposals, as per the rules, guidelines. If you really approach all these guidelines, definitely one day we will really reach Swachh Bharat's mission targets, as well as whatever all the inputs from various sectors, engineers, as well as scientific community coming into this. So thanks a lot for giving this opportunity. A small presentation I thought of exposing to you all and the importance of CIE in this area. Thanks a lot.
Thank you so much, sir, for giving elaborative talk on this this municipal solid waste management and your work for the integrated municipal solid waste to energy plant, and basically live demonstration of this particular work by Ramki Group. And we learned a lot from this particular your keynote address. And now I'll request Dr. Ashokan sir to tell a few words for Dr. Chakradhar.
Sir, thanks a lot, sir. In fact, it's an outstanding learning for us with a lot of full of practical implementation of the finding from the research. And I am sure the participant may be enjoying, and they will be further able to connect you. So how it can be multiplied in a different part of the country, different part of the states. That is the multiplier effect is very important. And also we have a submission in this forum, sir, to you. Maybe since
Please.
you have been involving and connecting all the policymakers and government organizations, where they are having a record information about the waste generation and waste utilization. Even when they make a report in the year 2021, the book is published. So when, as a researchers, when we look into that, that is the latest updated information like that. When we report that data, and when we go into very deep, we used to feel that the data is something very lower inside, maybe of 10 years, 15 years older in information. Though they also used to refer some resource. This is the reference for this value. But again, when we go into deep, the reference what they have cited is referred by maybe another 5 years older data. So for which, wherever, for example, simple example, the Central Power Electricity Authority of India released a booklet for more than 500-page document about the fly ash generation in the country. According to that booklet, it is a reference book for the year 2021. And whatever the value they have given, this is the quantity of ash generated in the country. And when we have seen at least 4-5 states itself generating more than that. And when we go into deep, and they have referred the year 2012, whatever the time the power plant were was commissioned. The time maybe of 2000 megawatt power, the power plant commissioned, maybe 15 years back. As on today, the same power plant commissioned for even 20,000 megawatt, some plant they are doing it. But
Yes.
they referred the one when it was commissioned. To avoid that interferences, we request, since you have direct link with our government sector, to influence upon whatever the data they are going to release a booklet proceeding, that should come from the State Pollution Control Board or MOEF, which has to be collected from the industry wise. They have to physically go to the industry, sit with the industry generation status, and record the data, and then they have to compile and publish it. That will be more significant. That interference, I know that you have the capacity, you have the linkages with the government. So maybe we have to convey them, make them to understand the importance and work accordingly. This is my submission. Thank you so much for your valuable time, and you know that how busy schedule you are. Still, you created your time to share your expertise in this part. Thanks a lot.
Okay. Thanks. Thanks, everybody.
Thanks, sir. Thank you so much, sir. Now, friends, there is a time of technology presentation. Now, I'll request, first of all, I'll welcome Dr. Indranil Chaturaj, sir, Director, CSR NML Jamshedpur. He will chair this session, and I'll request him to address the session chair. Sir, Chaturaj, sir.
He was there, he will be coming. Yeah, he's there.
Yes. So, I once again request Dr. Chaturaj sir for giving his address for session chair.
Voice is not coming, sir. You can continue.
Sir, we are not listening your voice, sir. Yes, sir. Sir, your mic is muted.
First of all, I congratulate. Can you hear me now?
Yes, sir. Yes, sir. Come, sir, and
Can you hear me?
I request. Yes, sir.
Okay.
Yes.
First of all, a very good afternoon to Dr. Srivastav, Dr. Anandwali, Dr. Ashokan Pappu, all the participants to this very important iCEN activity event. As you would be knowing, CSR has possibly the most comprehensive capabilities with regards to waste, with regards to valorization of waste. And we have been dealing with industrial waste, domestic waste, any kind of waste, and trying to find values out of that. And I must congratulate AMPRI on organizing this very important event. If you look at the importance of waste to our economy, the Indian economy, the amount of values that can be generated from the waste and which at present are under-generated is tremendous. If you look at metal values, for instance, many of our metal resources will be from these secondary resources, namely the waste. For instance, we do not have lithium, we do not have a number of rare earths, we do not have nickel, cobalt in substantial amounts in our natural resources. And we have to resort to industrial waste for all of these. Apart from that, of course, there are a number of other non-metallic values in waste. And this particular event is focusing on non-metallic values. Having said that, let me also add that we have conducted similar events on metallic waste. We have conducted events on how to utilize and valorize electronic waste, for instance, as well as a number of other metal plants waste like steel slags, like copper slags, all of these different kinds of waste. I know that AMPRI has been one of the leaders in this particular area, especially when it comes to valorizing non-metallic waste. And the group led by Dr. Pappu and many others in AMPRI have converted waste into very good non-metallic values and into very good non-metallic components, which I'm sure during the course of the discussion in this particular symposium, in this particular event, will be brought about. The whole idea of the iCEN activities is in the end to exhilarate as well as excite the industries and to build a connect with them, so that whatever are the technologies, whatever is the knowledge base which is available with CSIR as a whole is eventually utilized by the industry. That is the whole intent and aim of this particular event. And I must beg Dr. Srivastav to kindly allow me to leave shortly because I have another important meeting, but I would have loved to attend this in its entirety. So, and the loss is definitely mine. So I will request him to kindly excuse me. But having said that, I look forward to hearing from many of my colleagues at NML who are attending this particular event as to how it went, and I want to hear from them the details of this particular event. I must thank all the industrial participants in this particular event for their very valuable thoughts. I was just listening to Dr. Chakradhar, which was on managing of waste, which was a very insightful presentation. I'm sure similar such presentations will follow in this part of the discussion as well. So once again, congratulations to AMPRI on this very important event, and thank you for making me a part of this particular event. Thank you, Dr. Srivastav.
Thank you, Dr. Chitraraj. Thanks for your kind words. Thank you.
Thanks, sir. So thank you so much, Chitraraj sir, and thanks to our director sir, who is already there with us. So now there is a time to for presentation by Dr. A.K. Sinha, Senior Principal Scientist, CSIR, CRI, New Delhi. He will talk about the utilization of phosphogypsum for road construction. So I'll invite Dr. A.K. Sinha for his presentation. Slides are visible. Welcome, Dr. Sinha.
Good afternoon to everybody. Myself, Sinha from CSIR CRI. I am audible?
Yes, sir, you are audible.
Okay. Good afternoon, sir. Now I am going to present regarding the application of phosphogypsum waste material. It is a kind of waste material which is produced from the fertilizer industries. So with CRI experiences, I will present regarding the application of phosphogypsum. About 12 million tons per year it is produced, and around 40 to 50% phosphogypsum based materials. Currently, it is going to be utilized in cement or fertilizer industries, and remaining 50% simply dumped by the respective producing industries in a slurry form in a different ponds, and it is occupying costly lands of about 100 million tons produced per year. Already deposited 100 million
Sir,
tons at PPL.
may I request Dr. Sinha, sir, your slides are not moving.
It is not moving.
Yes, first slide only we could able to see.
Not second one.
No. Just unshare and again share your presentation.
Okay. It is moving. It is moving.
Yes, yes, it is moving.
Parvati?
Share your presentation, again share it, sir.
Okay. Okay. क्या कल वाला सीन है?
स्क्रीन नहीं आ रहा, फिर बंद हो गया ना। सही है।
Now it is coming.
Sir, it's
It is
coming.
moving. Slide is also moving.
Yes, yes.
Okay.
Yes, sir, yes, sir. Thanks.
So
Please
now
start your
again I will start from the beginning. So phosphogypsum
Yes.
waste material, it is going to be generated. It is from phosphogypsum fertilizer industries, and you will see around 50% it is utilized in different industries by cement or fertilizer industry. And remaining 50% is balanced 50% is deposited in different ponds in a slurry form of the respective producing industries. So if you will see, fertilizer industry is located in all over pan-India basis. It means phosphogypsum waste material are being generating in all over the country. So considering that, a study was carried out, and if you will see, phosphogypsum is a waste material, has potential for application in road construction due to uh, even basic research is also not carried out in India or as well as in abroad also, and due to that a study was carried out. So before application of phosphogypsum waste materials, certain challenges are there before application that. For particular application in road construction, first material should be aggregated by IRC, and this material is not till date, it is aggregated by the IRC, and there is no any guidelines, there is no any construction methodology available, lack of a skill. Even engineering properties, we are not certain how it will behave like this. So considering that, a study was carried out. So sequence of studies, step by step, studies was carried out to know the hazardous nature of the phosphogypsum waste material. Chemical analysis was carried out, and after that, it was found that it is a non-hazardous materials. Then forward direction, engineering properties were determined as per the requirement of road construction and standard specification. After meeting the engineering properties and preparation of reports, accreditation was taken from the Indian Road Congress. After taking accreditation of these materials, a pilot study using phosphogypsum in the construction of road performance study was carried out. 3 years performance study was carried out, and based on that, guidelines preparation is in progress by IRC with the help of CRRI. Phosphogypsum was studies in the construction of embankment layer, subgrade layer, and subbase layer as a replacement of soil or aggregate without mixing, without blending with other additive materials like soil or other chemical like cement or lime. So alone, phosphogypsum studies for application in different layers of road construction. As per the requirement Ministry of Guidelines or Indian Road Congress Associations, for embankment construction, these properties are required. For subgrade construction, these properties like liquid limit, plastic limit, isentity, free-settling index, shear strength parameter, all those things parameter should be required as per the Ministry guidelines for embankment, subgrade and subbase layers. Whole methodology was carried out in two stages. First of all, laboratory study was carried out, and then based on laboratory results, physical, chemical, or geotechnical characterization, design stability was carried out of the embankments, and after getting a stable embankments, field study was carried out using phosphogypsum layers, and 3 years performance monitoring was carried out. These are the physical and chemical tests were carried out on phosphogypsum based materials. This is the ACM and this is the EDS photographs, and this is the XRD photographs. And TCLP test was also carried out to know the hazardous nature, and it was found that as per Ministry of Foreign Climate Change Guidelines 2016, all heavy metal concentration are within the permissible limits. Geotechnical parameters were evaluated, and all geotechnical parameters were compared with MORTH specification, and it was found that these specifications are meeting with the standard specification. These are the properties of phosphogypsum, general properties of phosphogypsum compared with the soil also. And this is the stability analysis. Based on that, based on laboratory studies, a pilot study was carried out at Paradeep, Odisha. 5 sections were made. 5 sections were constructed using phosphogypsum. First one is control section, which is constructed as usual using conventional soil and aggregate materials. In second and third was constructed using phosphogypsum as a only embankment material. Rest layers were constructed as usual as conventional layers. And fourth one section was carried out using Xerophix as a subgrade materials. And fifth one, phosphogypsum as a replacement of aggregate in a granular subbase layer was used. This is the fifth 1, 2, 3, 4, 5 section where phosphogypsum material was used. This is the conventional section. This is the second one is phosphogypsum was used in only embankments. Phosphogypsum was used in embankment. Here, embankment slope was covered with locally available soil to know the erodibility of the phosphogypsum material on sloping ground. Fourth section where phosphogypsum was used in the subgrade layer. Fifth one section phosphogypsum was used only in granular surface layers. This is the pictorial view of the site where phosphogypsum was as the experimental section was carried out. This is the clearing grubbing. This is a totally waterlogged area and marshy lands. This is clearing grubbing was also very difficult to do that. During that time, the working platform was made, and then whole alignment was constructed. And after working platform construction, the phosphogypsum was aspirated and laid there. And this is the control section, laying of control section and compaction of control section. This is the compacted of phosphogypsum layers, and slope cover was also carried out like this. And this is the pictorial view of the embankment constructed using phosphogypsum, compacted layers, and then during the construction, different parameters like density, settlement, and CBR test was carried out, and modulus, settlement parameters, and field CBR was also carried out using DCPT equipments. For higher layer, bituminous layers, quality control was at the plant, hot mix plant, alignment, all the this is the alignment of the first pictorial view of the proposed road, and this is during the construction, temperature, thickness, all those parameters were measured. And this is the pictorial view of the finished experimental test section using Xerophix. And this is the details of the project which was carried out in the supervision of CSIR, CRRI, and different 3 years performance monitoring was carried out using different equipments, deflection parameter, roughness, and visual inspection was carried out for 3 years. And this is the pictorial view of the measurement of deflection under the right wheel path and under the left wheel path. And this is the roughness measurement using dip stick on the right wheel path and left wheel path. And it was found that all sections rebound deflection are comparable to a conventional section. Similarly, the roughness was also obtained. These are the comparable to conventional section. From this, we can say that phosphogypsum behavior of phosphogypsum as a embankment material or as a subgrade material or as a granular subbase material, it is good, or we can say it is better performing than conventional sections, and the roughness parameter is less than a conventional section. Rebound deflection is also less than this one, and modulus and severe value obtained from the experimental section is more than conventional swell section. Now, thank you. This is our presentation.
Thank you so much, sir. Dr. Sinha, sir. You have elaborately told about the bulk utilization of phosphogypsum for road construction. You have also told about the TCLP testing, basically for this soil stabilization, and it's very important for that. And you have done a very marvelous work on this particular aspect. And we, I think, all audience have learned a lot with this particular presentation. So once again, thanks for giving this very beautiful talk on utilization of phosphogypsum for road construction. Thank you so much. And now I'll request second speaker of this particular session, Rohit B. Meshram, Senior Scientist from CSIR NML, Jamshedpur, for giving a talk on quick repairing material by geopolymerization.
Hello. Hello, am I audible?
Yeah. So I am Dr. Manish Mudgal. I am inviting you for this particular event. So Rohitji, please share your presentation and start your presentation. You are being given 15 minutes for this particular presentation.
Okay,
Please.
sir. Thank you, sir. Good afternoon to all. My name is Rohit Mishra, and I'm sharing my presentation.
Vanessa, ये नहीं आया मुस्ताकिम
नहीं आया
आई नहीं
The slides are visible, sir?
Yeah, it's visible. You can start your presentation.
Yeah. First, I would like to thank the Director of AMPRI Bhopal, CSIR ACRP Chennai, the Director of CSIR NML, Mr. Suresh from Aditya Birla, and Dr. B. Chakradhar from Resustainability for giving me the opportunity to showcase the NML technology at iConnect event. I'm also thankful to all the dignitaries present in this meeting. So my topic of the presentation is quick repairing material by the geopolymerization. NML has already transferred this technology to a firm in Hyderabad. We have actually considered the road potholes, road repairing for this quick repairing material, and to check the available market, we have to just look at the road networks and the construction in India. So, what is the recent advancement in road construction in India? So, India has the second largest road network in the world, spanning of over 5.8 million kilometers, and over 65% of the goods in the country are transported through the roads, while the 90% of the total passenger traffic use the road network for day-to-day commute. Highway construction in India is increased at the rate of 17% CAGR between 2016 to 2021. And despite of the pandemic and lockdown, India has constructed over 13,000 kilometers highway in year 2021. However, over the years, these um, heavy traffic and change in the climate leaves the road surfaces, which results into potholes and uneven surfaces. Also, the broken roads, cracking, which certainly causes the accident on the roads. Nowadays, the roads are not black but are gray, as the concrete roads are more popular nowadays. These are made up of the cement, aggregates, sand. So Joseph Aspidin discovered the Portland cement in 1824. The reason for the use of concrete in place of the asphalt is the longevity, which is around 20 to 40 years in an average. It is also higher, 2 to 4 times higher than the lifespan of the asphalt, and also the recyclability, as the concrete can be recycled means can be used as an aggregate again for the next cycle, and the hold up is better for the concrete road under the weight and the pressure conditions. However, there are some disadvantages, and the main is the cost of the concrete, of course, and the second one is the repairing is the big problem of this concrete road. So these disadvantages can be catered using the geopolymers, and Joseph Davidovich coined the term geopolymers in 1983. The pyramids blocks are the best example of the geopolymers. Uh, so the geopolymers are the inorganic, typically aluminosilicate materials, uh, form the long range of covalently bonded amorphous networks. It has the properties of fast settling and ambient temperature. They are more durable than the conventional cement or concrete structure, and they have the more higher compressive strength as well as the tensile strength. And they are produced using the waste material and the byproducts. When we are talking of the waste, these are generally the thermal power plant waste, and byproduct is the metallurgical industry byproduct. Okay, so when we are using these materials in our technology, we have to look for their availability also in the future. So the main raw materials we are using in our technology of keep repairing geopolymer is the fly ash and the slag. So we will look at the fly ash availability. So the Indian coal-based thermal power plants are the backbone of the power capacity addition in India, and the Indian coal has a higher low-grade ash content of around 24 to 63% as compared to the imported coal, which has around 2 to 18% of ash content. This larger quantity of ash not only requires the large area of land for its disposal, but is also a source of a pollution of air and water. These graphs reports the fly ash generation and utilization status in the country of year 2020 and 2021 half year, and source is CE report of 2020-22. The second raw material we are using is the slag. It is actually the byproduct generated during the pig and steel production. It is the major waste generated in the integrated steel plant. It contains calcium, magnesium, manganese, aluminum silicate, and oxide in various combinations, and nearly more than half a ton get generated for each ton of steel production. So nearly 24 million tons of blast furnace slag and 12 million tons of steel slag produced in India annually, and it is expected that the blast furnace slag generation may reach up to 45 to 50 million tons, and the BO slag will be generated at around 15 to 20 million tons by year 23. So using these raw materials, we have actually developed the process for quick repairing material. So the raw materials like tires, GVFS, and additives are mixed and packed in, and also the similarly the liquid activators or solutions are also mixed and packed, and both can be uh, applied on the potholes or the road repairs. So this technology is also already awarded with the Altaker Award for the best technology in 2018 by CSR Elements. So the product has the different highlights, like it's suitable for the roads and other civil structure repairing. It is ready to use and instantly set. It works in all weather conditions, and it is ready. The road can be used for light traffic in 6 hours and moderate traffic in 12 hours. It has higher shelf life, and it is very environmental friendly, as we are using only the waste material or the byproducts, and it is also very economical, as the fly ash and the slag are available with the industry at the nominal cost. It's just for the fly ash, it is only the transportation cost is considered. So the two products we have developed, like based on their setting times, one is at the minimum of the 40, that is quick set, and another one at sets within the 30 minutes, that is uh, uh, ultra quick set. And the compressive strength for after 28 days, it is as per the ASME standard, and the shrink, we have not found any shrinkage. So the workability for this material is within the 15 to 30 minutes. That is sets very fast. We have also done the product comparison uh, with the market available products like from the BSF and Pidilite Industries, and also we have found that it is much cheaper, like around 50% to one third of the available products, as all are the import products. So it will be the import substitution for the quick repairing material. So we have done the just techno-economics for a 1 day per day, 1 ton per day powder production, and we are using around. I'm not actually putting all the exact values, but the ranges are mentioned for the idea, and we have calculated the production cost after including the GST, and the it is around as I already mentioned, it is around 7,200 per ton. So, so based on this, the recovery on investment is only nearly 4 years. So, which is acceptable. Like below 5 years, it is acceptable in the industry. And this, sorry, and this technology I already mentioned, it is demonstrated and transferred to the industry in Hyderabad. So there are the three advantages for the industries, like it reduces the greenhouse gases. Like you already know that 1 ton of cement emits around 870 kg of CO2. Uh, and for the geopolymer cement, geopolymer quick repairing material, it is around 350 to 400 kg of CO2 per ton. So it is very less. Uh, it actually helps to reserve the natural resources like limestone, and the cost is also minimum because we are using the waste and the byproduct. So this is a photograph of the technology we have demonstrated at 100 kg scale at Hyderabad. This is a photograph shared by the client, and we have the application areas of the repairing of the common defects of occur in the road, and also you can use it for the cracks on the wall structures also. So thank you. If you have any question, please.
Thank you, Dr. Meshram, for this innovative work on quick repairing material by geopolymerization. Oh, nice presentation. And good thing is that you have completed in very short duration of time. That is a specific this for 15 minutes. So thanks, Mr. Mishra. Now I'll request Dr. K.N. Lakshmi Kandhan, Senior Scientist, CSIR, SERC Chennai, for delivering his talk on toilet unit using thin precast concrete segment panels. So, are you there?
Yes. Very good evening to one and all.
Yes, sir. So, myself, Dr. Manish Mudgal from CSIR EMPRI. So, once again, welcome for this to this particular iConnect program. So, please start your presentation. So, 15 minutes is given for this particular presentation. Yes, your slides are visible. You start from first slide, yeah.
Respected directors and dignitaries, very good evening to one and all. This presentation is related to the product which is developed at the SERC Chennai. This is basically we are developed this technology to address the Swachh Bharat mission. We found that there is a massive demand existing in the field, so we developed this technology, and the main focus of this technology is we want to develop a technology which is having most efficient in cost as well as technology aspects, and also it can be suitable for the factory mode of casting and delivering to the field. And also we want to concentrate on the quality aspects, and we targeted to reduce the time of construction at least by 90% compared to the conventional construction aspects. So these are our main aim we kept in between development of this technology. So Swachh Bharat mission, it is a great vision of our PM for giving the toilet to everyone. But these are some of the quality related issues which are existing in the field now due to this technology lackiness or the lack of awareness. So we want to consider all the aspects which are concerning for the implementation as well as for the usefulness of the technology. Aiming for the using maintenance. The maintenance is seems to be a major issue in case of the service core units. And the ventilation and daylights, these are all the prime factor we keep in mind for developing this technology. And also it is should be suitable for the industrialization so that we can produce at the factory and so that we can transfer this technology to the field for the installation or at the minimum cost toilets. And size also we fixed so that we can access, because the inconvenience would not be the problem for the user. So we fix the size and everything because it's a precast, so we fix the size. And we want to see that this technology is a green and sustainable technology. And for this one, what we made is we developed a flowable concrete mix. In general practice, the porous cement is a technology which we are going to use in this concern. The porous cement construction is there will be a meshes and it will be plastered with the mortar. Here, what we want to develop the technology by casting with the concrete. So, and also we want to develop a system which is a damper-proof jointing system, so that we can install the individual components without any complications or difficulties. And we want to restrict the foundation, because foundation we want to 100% restrict, and also the plastering we want to restrict. So these are some of the foreseen concepts we kept for developing this technology. Also, and this technology we are very keen. There is no brickwork to be carried out for developing this technology because of the clay usage and reforestation or burning the country wood dampness. These are the many factors which is against the brick usage. So we want to 100% reduce the brick usage. So it is suitable for both Indian and Western classes. So finally, what we ultimate aim is this system, whatever we are developing, should capable to provide a water tanks as well as for the septic tanks. These are the main concept what we kept behind this technology. So ferrocement is one of the technology what we are choosing for this all the satisfy all these aims, which is a corrosion resistance and green and sustainable. This is, and also we want to concentrate on waste to wealth. So these are the three compositions we want to use for developing the ferrocement for this technology. So ferrocement is a very good in my aspect, and this is a material. So even though it was a composition of the finer mesh and cement mortar or concrete, so when you are combining these two, this will try to act together, not a separate like an RC system. So when you are seeing this system, this is a very fine mesh. Because of the fine mesh, the corrosion resistance will be very high compared to the other RC structures. So normally the volumetric changes of the iron to iron oxides, and there will be a sevenfold that is 7 times the volume it can enlarge. So if you take the diameter of bar is D, then 70 expansion is expected. So because of this large expansion, which is giving stresses and breaking the concrete, is not normally what it's happening. But in case of ferrocement, we are using a very finer mesh. So because of the very smaller diameter, whatever the expansion is trying to happen will be controlled by the tension characteristics of the concrete. So we are expecting the ferrocement is a good corrosion resistive material aspects. Another one more thing we want to utilize the industrial waste like GGBS or fly ash. So this is the basic chemistry behind this the process of concreting. There will be a CSH gel which is forming when we were adding this water to cement, and there is a remaining about 20 to 25% of the calcium hydroxide which is kept idle in the concreting process. Actually, this is a very good for in terms of the durability aspects. So this will keep the pH in between 12 to 12.5 to 13.5 pH level, so that the possibility of corrosion will be restricted. But actually, what the quantity of this one requires around 5%. In 5 to 7% is normally what we record for keep the pH value. So remaining the 13% we can effectively utilize for developing the good characteristics of the concrete. So here what we were doing is we are replacing this pozzolanic material like fly ash or GGBS, which is the industrial waste from the industries, and then this will react with the calcium hydroxide which forms against this CSH gel. So this way we can effectively utilize this waste material for producing the better concreting material which is having. So when you are reacting with, when you are reducing this calcium hydroxide to calcium CSH gel, then it will be become the force to non-permeable concrete system. So this way we are resisting the possibility of entering the water or that is moisture or air into the concrete medium. So it will give the better durability aspect. So we planned such that way it should be a very easy to cast, and it should not create any damages during the handling. Also, it is easy to fix and go for the installations. So everything we kept in mind. So we planned accordingly, and we developed the concepts for the developing this technology. And these are the different, and also we want to use the each and every part is a precast, and that should be assembled. That is our main aim. So that we made everything is in a 7 categorized way. So totally the 6 is the for application for this service core product, and the remaining 2 is the additional add-on products. So everything we programmed and we developed this technology as a single end complete use technology. So we developed for this one. We developed the design mixes. Those design mix should have the good flowability, and so we different mixes we you develop trial, and with that we found that the players of with the 40% replacement of cement will giving the very better flow characteristics, as well as there is no segregation of the cement slurry is not happening in the mix. So we chosen this mix for casting all the products. So this is a typical view of different components which are we developed. This one is the basic material which is used for supporting the system, as well as for this is for providing the class edge panels, and these are different wall panels. The technology what we developed also with the tiles. Tiles will be provided at this before casting, and then casting will be done, so that obviously the system will have the tiled surface, so that we can get a very good finished surfaces inside, so that it can lead to minimum maintenance of the system. So we developed shells for having good ventilation, as well as for airflow, which is creating a heady current into this toilet system, so that whatever the heat which we suppose the air is coming in this direction, it will go into the this eddy current action, and so it will give you a road that is it will take it up the heat to the outside, so that we want to maintain the system that is the entire system will be a cooler as well as it is a daylighted. So we developed a dry joint system, and we trialed this at the laboratory, and we found that within a 2.5 hours of time, it is able to complete a single toilet. The meaning is within a 3 hours, we can go for usage. That is what is the expectation what we initially aimed. And similar way, for also we want to aim for the cluster of toilets for community usage. So it can be this is a 2 toilet system, which one is we are shown here. Similar way, we can expand for 3 or 4 or n number of toilets can be extended. So same the ferrocement technology we used to develop water tanks, as well as for the septic tank. Here the septic tanks what we develop, we are having the concept like the one setup can be used for some time, and it will be closed, and then the second one will be open, so that we are providing a drying opportunity for the this system, so that the long-term usage of the entire structure is ensured. So this is actually the technology what we were developed having the 4 poles. This is the first pole technology what we developed. The only problem what we were facing here is because of the luxuriousness of the entire system. The cost will be very, very high compared to the whatever the convention that is the conventionally available system. Here the toilet which we are developing is around 22,000 per unit. So we want to overcome this technology. We further refined and with a final system. So we are tried different options. One is we are developing a superstructure systems separately, and then substructure system separately. So with this way of we can able to reduce the cost, which can be a competitive with the market. So here also we tried the different the thickness of the panels. So here the one panel is consisting of the 10 mm thickness. Just imagine it's just 10 mm thickness, and this is 2.2 meter height of the wall, which is having weight of only the 108 kg. The second wall we kept for the 15 mm, and the third one for the 20 mm, and fourth one for the 25 mm. This is we constructed to examine whether the expectation regarding the durability aspect and corrosion is it is fulfilling or not. So in the second technology, we developed the complete from the foundations, the substructure system to superstructure system, every integrated with the segmental panels. So this is another one more example of segmental panel systems. Here, what we achieved is a system can be developed and can be delivered at the user end at a cost of 11,900 rupees, but we with a reduced size of 4/3. So another one difficulty is, that is the one drawback what we face here, is the time. So here we taken 2 time to install this 2 days for installing this system. So this is obviously we want to control on the time of installation, and also actual expectations we want to keep the water tank over that one, and we want to the good and excellent ventilations. So all these things we were just missing. So we want to rectify this one. The further we expanded this technology. So this is a typical view of some of the things we demonstrated TTRS in our Chennai region, which is a tower testing facility for CRC. There we installed 5 units, and in this 5 units, 2 units we used for security cabins. This is the security cabin which is installed at the elevator level by carrying panels to this levels. So this is seems to be a good technology. The only drawback is the weight which we were developing is around 180 kgs. So 180 kgs we want to reduce further, so that we divided this into a different number of panels. So the 4th fold we developed this technology with a precast foundation system, and then 4 corner walls with the sliding ribs, and then we developed this cement panels of 20 mm thickness, and we assemble all these components within a day. So within a day, we can able to complete the structure, and then other aspects of the painting and other aspects can be done whenever it's possible. So this way we able to control on the time as well as the cost. So this technology, what we were developed, it is suitable for both single service core unit system or a multiple service core units system by modifying the ribs which are having that grooves which are present in these ribs. So cost also it is comparable compared to the market price. It is 1,200 rupees per unit for a single system, and if you are going for a combined system, it is coming under 11,500 per unit. So this is an appreciation letter. This technology we were demonstrated for CLRI and for the KV as well as for the school regions, and the appreciation letter is this appreciation letter given by Director CLRI. He seems to is feeling that the technology is a very good technology, and it is having the excellent there is potential for the market. And we also transfer the technologies to 3 concerns for demonstration. So with this one, this is about the service core units. Now further, we want to extend this technology for developing a housing units, because the ferrocement, which is having a good structural characteristics as well as the durability and ductility and whatever may be that requirement for the basic design aspects, it is having very good. So we want to use all these informations and the effectiveness of the structural system. We want to develop a housing system which is having a very good opportunity for implementation. And we want to use the waste, which is we are what we were having a residue in nature, have to be used as a resources for developments. So this is a basic fundamental study we studied, and found that the ferrocement wall, which is having the capability of carrying the whatever load it comes to the system, at least for G+2. This is the experiments what we were done for the G+2 structures, and we found that it is suitable. But what's the problem we are facing is here the thin system, because it's a 20 mm or 25 mm thickness of the wall, which is not having a sufficient thermal or sound insulations. So we want to keep this one in mind. So we would we further develop this technology by providing a further one more skin at this end, so that there will be an interface between the 2 skins, and that 2 skins will give a good thermal insulation as well as sound insulations. So we further extended this technology. This is what the technology it's available in the market, 3D truss systems, and we developed our own system, and we patented this technology for named as a securable panel system, which is having a EPS or any other the waste which we were found in the in and around our field. So here the ferrocement will be cast on the both side of the skin, like what we were seeing is a 20 or 25 mm thickness skin outer to outer, and here inside there will be a EPS. Or instead of EPS, there is a one major problem what we were facing is the plastic. The plastic water bottles or any other water bottles or plastic papers, carry bags, what on the coconut shells or reed or any the straw, whatever may be the industry, that industry from waste or agricultural waste, can be used as a infill material, and we can develop a panel system. This is an excellent ferrocement panel system which we were developed, and we patented this technology for market. So this technology is readily available. So before going for the market, we tested all the aspects in the flexural as well as for the axial compression, and then also we tested how the behavior of the panel with 1 meter by 1 meter or a large panel with 1 meter by 3 meter size. So we kept the thicknesses 150 mm, including which includes 25 mm skin at the both the end and 100 mm thickness of infills. So also we developed a model house. So normally when you are telling about the precast construction, the one-way slab is most preferred the system. But here using this our securable technology, we proved that it is suitable for the two-way action. We tested this with a 12-point loading, which simulates the equal UDL load distributions. And this is the crack pattern. The crack pattern clearly shows us it is a two-way distribution of the crack. So this 100% proves this technology is well suitable for two-way slab action. And there is no punching shear because the single, that is points, 12 points we were holding in this one. So no point is here the crushed or punching will be happen. So that shows that the panel, the integration or integrity which is ensured for the load carrying capacity. And this is a typical view of G+1 building we developed using this acrobal technology. And we tested this for lateral seismic load. And we found out this is well suitable for any of the worst seismic conditions. Thank you. Any questions, please? This technology is readily available for industrial people. They can take up this technology for their implementation. Thank you.
Thanks, Dr. K.N. Lakshmikandam Saab, for giving this elaborate talk on toilet units using thin precast concrete segment panels. So, anybody is having any questions, you can ask him. Otherwise, we can move to next speaker and last speaker of this particular event.
Can I ask? Hello.
Please, sir, please.
Can I ask one question, Mr. Manigan?
Please, sir, please.
See, when you are using this ferro cement, how much and the thickness, because ferro cement is not a new thing, you know, ferro cement has been used for water tanks and other things, you know, long back. And then what gain you have got, like what is the costing which is coming for this ferro cement per square meter or so, especially because see, everything is cost sensitive, and precast means you have to do it has to be done in a factory setup. And because machines also will be required to do this type of work. So mechanization, because until unless you think about the mechanization of this product, this is not going to work. So my suggestion to you will be to find solution out of, because housing, there are a lot of solutions which are coming up, and you know, housing adaptation of the new technologies, it is very difficult. I've been pushing this precast technology to various stakeholders from last 10 years. Now at least the situation arises, they don't ask that why precast is to be adopted. But yes, because the challenge in using this type of technology is, especially the toilet thing is very nice, in which you have used that. So that thing, can it be emulated for this water tanks? Because now water tanks are one of the major challenges because we are looking for solutions in precast water tank.
Can I
elevated water tanks, right?
Yes.
Please.
Very nice question, and actually it is
actually maybe
there is another
Suresh sir is there.
Yes, sir.
Actually, just wanted to know, you exactly pointed out the significance and the need of the technology or the product. Similar to the same process know-how. Tomorrow we have a presentation particularly with this type of process and how water tank can be manufactured. Tomorrow session it is there.
Okay.
Maybe
okay.
I will tomorrow another one scientist is presenting.
Okay. Right.
And I think that is also prefabricated ferro cement based panel for instant water tank applications. That will give you a complete feedback for you, I think.
Yeah,
But
that
during
will
that
be
time,
okay, because when you are using very thin element, then
right.
our codal provisions come into this one, you know, lot of problem, because the thickness, minimum thickness have to be adopted, covers have to be provided, all those things have to be taken into consideration. Yes, when you design it as a shell, then codal provision becomes different. So you can design using shell as this one. So yes, these are very much very innovative, sir. Thank you for enlightening. But yes, I also foresee a lot of new products which can be made in this because I was trying this only with the conventional ferro cement, but that was coming, cost was coming very high. And one issue which I had in that was that we had, because it is very labor intensive thing, until unless you mechanize the precast construction, you are not going to bring the cost down. And when you have to do a lot of elements together, you have to focus on mechanization of these type of technologies.
Yes, yes.
So I just wanted to add that, sir.
Yeah, maybe I can request Dr. Krishnakant, you may have to connect with Shri Suresh Tripathi ji, so that how both of you can connect to the government of India. There is some schemes are there for upscaling and automation and mechanization process. How even under the Nimitli program, I can request Dr. Krishnakant, under CSAR Nimitli program, there is a provision for funding. With Shri Suresh Tripathi ji, you can combinedly you can have, so that the funding also will be available for both the organization. So mechanization can go up for upscaling. That will really make a game changer to the country for rural sector as well as for urban sector also.
I look forward, sir. Thank you. Thank you, sir.
Yes, maybe Dr. Krishnakant, this corrosion behavior, I do not know. Maybe I am sure you might have studied about the corrosion characteristics. That maybe I will contact you separately, since already the time is moving upon. I would like to sincerely thank Suresh sir and the present Dr. Lakshmi Kantan for very interactive session in this. And I am sure these are all the point, something we have to highlight upon on 15th of July, when we have a panel discussion. So with this, I am finishing my speech. I request the moderator to continue the program. Thank you so much.
Thank you, Dr. Ashokan sir. Thanks, Dr. Ashokan sir, for giving advice for this particular collaborative work. Definitely, this particular iConnect will be beneficial to all the presenters as well as participants who are participating in this prestigious event. Now I'll request Dr. P.S. Ambly, Principal Scientist, CSIR SERC Chennai, to deliver her talk on eco-friendly geopolymer concrete blocks. So, Emily madam, please. Dr. Lakshmi Kantan sir, please unshare your presentation so that next speaker can.
Yes.
Yeah. So once again, I'll invite Dr. P.S. Ambly madam. She is Principal Scientist, SERC Chennai. She will deliver a talk on eco-friendly geopolymer concrete blocks. Still, Dr. K.N. Lakshmi Kantam sir, you have not unshared the presentation. Please unshare your presentation. Yeah.
They are doing it, is looking clear.
Yes. Yes. Can you hear me, Dr. Emily ma'am? We could see your presentation. Yes, it's visible. You can start now.
She is speaking, I think.
I think your mic is muted. Can you hear me, Dr. Emily?
No voice.
No voice.
If there's something went wrong with us.
Yes.
Yeah. Dr. Emily, could you able to hear us?
Sir, hello, one second.
Yes, some. Yeah, your voice, can you hear us? Dr. Emily?
Sir, this is Dr.
Can
Lakshmi Kantan again. Sir,
Yeah.
actually we were sitting together and she is trying to load her presentation. The voice which is not
Yeah.
coming in that the common presenting medium. That's why she is taking a little bit time.
So you please,
Just 2
one
minutes,
of
sir.
you can close your presentation.
Hello, is it audible, sir?
Yeah, ma'am.
Sorry
Yeah.
for the delay.
Okay, just make it in slide mode.
Okay, sir. Is it visible, sir, right now?
It is visible. Just move on. Yes, it is visible. Now you are most welcome for this presentation.
Thank
You have
you,
been
sir.
given 15 minutes, Dr. Emily. After a long time, we are talking to you. So
Yes, sir.
most welcome to this particular iConnect. And please give your talk on eco-friendly geopolymer concrete blocks. Thank you.
Very good afternoon, respected directors, other coordinators, and other speakers, and dear participants. Myself, Ambali, I am working in the Advanced Materials Laboratory of CSR Structural Engineering Research Center. And the technology which I am going to present is eco-friendly geopolymer concrete blocks. And we have already, there are some few presentations were there previously on the geopolymer technologies. I'll be specifically focusing on building blocks and paver blocks using the geopolymer technology. And we are already aware that concrete is one of the biggest commodity used all over the world. And there is a lot of advancement is taking place in this field. And also it will be continuing and it will give a highly social impact to the world. And with respect to the concrete block technology is considered, we are already known, and lot of entrepreneurs and lot of people are working on the new type of concrete blocks technologies. But other than that, what happens when the cement concrete, we already know that because of the utilization of the cement, there is high embodied energy utilization is involved, and we are going for a technology which will be eco-friendly and at the same time low energy intensive. And the being one of the largest industry, construction industry today is focusing on sustainability and sustainable development. So our main focus for development of an eco-friendly material which will conserve the natural resources. So in any project, when we are thinking about developing a new material, it will be if a material which we can develop, which gives low impact to the environment, and also at the same time, it can be, if it is energy efficient and also water efficient, minimize utilization of waste and material efficiency. This will be a material which can give a lot of impact and which will be highly eco-friendly. And when you talk about the normal concrete, there are three basic ingredients like binder, aggregate, and water. And there are a lot of, due to the, over the years, there are a lot of advancement have been taken place, and there are a lot of new admixtures like chemical, both chemical as well as mineral admixtures people have started using, and apart normally ordinary Portland cement was using. That was the one of the main binder, but nowadays we cannot see normal Portland cement based concrete because there are a lot of other supplementary cementitious materials are incorporated. So blended cement have come, and this blended cement it can modify both in the hydration as well as the other properties of the concrete. So when you are using any blended cement based concrete system, or when you are adding any chemical mineral admixtures into the system, by careful formulation and optimization, we can have an improved performance. Even you can get a better performance than the conventional cement based system. So if you are looking, when you talk about concrete, we all know that it is a sustainable material. How it is sustainable? Because it is recyclable, it will reduce energy consumption, and at the same time it is economical compared to other building materials. But what happened? Where is the problem? Because we all know that even though cement is many years since its invention, we are using the cement based system, but the cement is high embodied energy is involved cement production. And also at the same time, lot of natural resources are also utilized in the production of the cement. So we are looking for some alternative solution, and one of the solution is alternative binder system, which that is it is a geopolymer system. It is proposed by Davidovitz 1978. It is an basic, and some introduction already has been given. It is basically an inorganic binder system, aluminate silicate based. In the case when you are using binder in the concrete system as geopolymer, the previous studies, it says that it is having excellent mechanical and durability properties, and also the properties are most of the time it is similar to the conventional Portland cement based systems. And in CSIR SCRC, past more than 2 decades, we are working on geopolymer system. There are different source materials which we have utilized for geopolymer. The main advantage is cement is a factory produced material, and it has certain properties that whatever maybe thing we can alter with the incorporation of other mineral admixtures or any other admixtures. But what happens here, from the source material modification itself, we can get different properties or whatever required properties to suit the customer requirement. So this geopolymer based technologies, it has been, there is a it is a profitable business, because depends upon the availability of the source material. The cost, it will vary. It can come down, or it can slightly go up, or it can be equivalent based on. And not only the cost is, we have to see the life cycle cost, not only the material cost, life cycle cost. When you are developing a technology, and when it comes to the application, then their life cycle cost has to be considered. So there are a lot of materials which we can utilize for the geopolymerization. So for example, fly ash, GGBS, metakaolin, the red mud, ricer's cash, etc. And we have used many source materials for geopolymer formulation. And depends upon the silicate to alumina ratio in the source material. It is there are different technologies also we can make it. And in short, we can say that wherever conventional cement based system is used, there we can utilize geopolymer as a binder. We can utilize, and there are a lot of advantages for this geopolymer concrete. So in other countries, in SCRC, we are talking about ambient cured geopolymer system, which is most work we have done on fly ash and slag blended systems. There's no Portland cement is used, and it is proved that it is eco-friendly, the low imported and easy to emission, and at the same, it is having high early stage. The geopolymer concrete system of the grade from M5 to M150 we have developed at CSIR SCRC. And it is fast setting, because most of the time we could see that in 14 days itself it will be around 90 to 95% of the 28 day strength is achieved. After that, there is not much improvement. And also there is no water is required for the curing purpose. It is highly durable. And we have studied both structural aspects as well as non-structural concrete components using geopolymer. And when we talk about the source material, depends upon the type, and depends, there are a lot of factors involved. For example, when you are taking fly ash, there is a lot variable nature because of the chemical and other mineral composition difference. So there can be variation occurs in due to the combustion condition, or the ash collection procedures, or how it is processed. So we have to see this variation, and then accordingly you have to formulate the mixer, then only you will achieve the target. Recently IS 17452 also some guidelines have been given for the precast products. for alkali acted cement and concrete system. So that can also be utilized for the production of different types of precast products. But it is limited up to M40 grade of concrete. And I am just going to give a brief overview of the previous work done factory scale demonstration for the block production. It is carried out in the year 2008 at Ions Construction Private Limited, Chennai. And the source material mainly we have utilized fly ash and GGBS and sodium hydrox flakes and sodium silicate solution. And also we may note that sodium hydrox, it is available in different forms like flakes, pellets, and also in the lye solution form. And sodium silicate, again it is available in powder as well as in solution form. And when you talk about any source material, the proper characterization is required, because we have to see what are the elemental composition present in the different source material, binder source material we are using. Accordingly, we have to, because we are looking at the silica and alumina. But when the presence of CAO, there is a different reaction also happens. Calcium silicate hydride based additional reaction also will happen. And if you look at, see, for example, silica fume and this MBS is micronized biomass silica. It is a Rice's cash, again, grinded version. So it will be having a particle size of less than 25 micron. And if you look at, both are high silica content, around 90 to 95% high silica content. But what happens? But when you look at the fineness, it is different. So we have to see all these properties when you are formulating the mixes. And also, again, even though it is having a particle size, there is a change, specific gravity. So all these factors we have to look at carefully. Again, when you are talking about the silicates used, commonly we are using sodium or potassium based silicate. And the main thing which we have to see, what is the Na2O and SiO2 content. And generally we will be going for about 0.6 to 2 ratio or something like that. And again, the viscosity, when you are going for about hydroxide solutions of about 10 molar when you are preparing, it will be having the workability. There are some issues. So it seems to be, it is more workable. Potassium based systems is more workable. And in the factory scale, we have used fine sand, coarse sand, as well as some hollow bricks, as well as using lightweight aggregate, fly ash based lightweight aggregate also. Some blocks have been produced other than the normal blocks of solid and solid paver blocks and building blocks. And there are two different high volume fly ash and GGB based mixes. We have arrived in the laboratory after several trials. And different grades of concrete have developed. This is a production view of production of the hollow blocks and solid blocks and stacking for ambient curing. And all the characterization or all the properties have been with respect to the IS code for the cement-based systems we have utilized at that time. And there are about 1,200 blocks we have produced for one trial batch, and it consists of solid block, hollow block. And this is the properties also. There are different paver blocks suiting to different traffic conditions, M30 to M50. It has been developed, and the standard deviation is given here for the building blocks and paver block. And the building blocks IS 2185 part 1 and part 2 utilized. And this is abrasion resistant for the paver blocks. It is produced. And to show how this ecological parameters is different from for the conventional concrete and this geopolymer concrete. From the literature, the data is available for the embodied energy and the embodied CO2 is nothing but the total energy right from the extraction and its process and production of the total energy required for the product to develop. For example, Portland cement means it is right from the source material, then the transportation and the process. Every process, what is the embodied energy? Similarly, for the CO2, it has been, this is the value, it has been taken, and some calculation for M40 grade it is made. Why I have chosen M40 grade is in our studies it is seen that M40 and above we can there is a cost saving also involved in the even the concrete production itself. That means material only it is coming into picture there itself. It is coming little bit slightly comparable. The cost wise it is comparable, but the main thing is like what embodied energy and ESO. There is a remarkable change reduction in the case of embodied energy and ECOT is observed for the geopolymer based systems. So for the M40 having 55 MB for GPC and 52 MB for OPC, these are the two quantities we have taken for comparison. And so geopolymer blocks, which we have developed, it has been used for the one of the demonstration which we have done for the KV CLRI building. And there are totally 4 technologies has been transferred to different industries, but all the 4 requirements, see, this is a technology where the user-friendly technology, because whatever the materials which are available in the hand, that we can utilize for that. So for example, suppose the fly ash, somebody may be coming with the fly ash, somebody may be coming with the GGB, somebody may be coming with metacal, somebody can, so there are different, so silica and alumina rich source material or its combination we can utilize for this film. For this example, the industry requirement or the customer consumer requirement also different. This is a one of the leading silicate manufacturers in Chennai, and they are into geopolymer production also, but they were facing some difficulties or some issues during their production of geopolymer products, so that they have approached us, and we have produced geopolymer pavers and building blocks, and we have demonstrated their factory. And it was a successful demonstration. And for them, how it is advantage, they are producing silicate. For them, that cost comes 0, because their raw material silicate, when they take it, it is 0 because it is already available with them. So that is a huge saving they could see in their production. There is another technology which is transferred to KPS Industries E-Road. Here, the specific requirement was there, that area, it is a Sipcot industrial area, where the total solid percentage is high. So they were looking for some solutions for a technology which requires less water for your curing and other purpose. So they came across the geopolymer technology, and they have approached us, and we have developed the technology, and it has been transferred. And another third thing, this Wasavi conduit solution, it is in Kurnool. This is again, there is a specific requirement, like this concerned person is a chartered account, and he was they were having some jasmine farms, and nearby some thermal power stations were there. So this dust from the, or fly ash particles from the thermal plant, it was flying, and it is coming to the jasmine flower. So he was looking for a solution. So then he was thinking like, okay, nearby some fly ash is available. He wanted to convert some area of acres into production of or utilization of this blocks production. Then he approaches, he is developed 10 acres land, he has converted, he has now plant is established. We laboratory trials already using lightweight blocks, he wanted lightweight geopolymer blocks he was looking for. We have developed all the laboratory trials, it is completed. Now we have to go for a demonstration. Due to COVID, there was some delay for the plant setup. And coming to the fourth, this one, we have recently signed an MOU with this Debris Conduit Labs Private Limited, Chennai, IIT Research Park. This is the specific requirement is like lightweight structure. They were looking for one, see, for example, prefabricated structures, they want to erect it in one day. So they want to make a platform using blocks, and that has to get around 20 MBA in 10 to 15 hours. That's what the requirement. And in one day itself, they want to erect their building system. And that was the specific requirement. Now about some trial mixes, everything has done. Now we have to go for the final field demonstration. These are the few technology transfers also it has happened. Apart from that, we are working on geopolymer form concrete, then ultra high performance geopolymer concrete. And also there are a lot of other specific requirement like pavement, etc. Also we have been working. So thank you. With this, any queries we can have it.
Thanks, Dr. Emily, for giving such a nice presentation on polymeric blocks. If anybody is having any question, you can ask her. So if there is no questions, so I would like to thank all the presenters, and I'll invite Dr. Deepti Mishra, Senior Principal Scientist from CSIR EMPRI Bhopal. She is our colleague. She will give the formal vote of thanks for this particular iConnect event.
Thank you, Dr. Manish Mudgal. Thank you, Dr. Manish Mudgal, and good afternoon, everybody. It's my pleasure to propose a vote of thanks. And regarding this, first of all, we would like to thank Dr. N. Anandavali, Director CSR SCRC Chennai, Team Nodal CIE, for her support in organization of Industry Meet 2022 on Waste to Wealth, as well as her opening remarks. Dr. Avnish Kumar Shrivastava, Director CSR MP Bhopal, for his valuable guidance, support in organization of this meet, as well as introductory address. Thanks are due to Dr. Vibha Malhotra Sahne, Scientist H, Head TMD and IPO CSR New Delhi, for her cooperation and support for organization of the event. We would like to thank Shri Suresh C. Tripathi, Senior Consultant, Novocrete and former Senior General Manager, Aditya Birla Group, for giving plenary talk entitled Opportunity for Construction Industry for Usage of C&D and Other Inorganic Waste. We would like to thank Dr. B. Chakradhar, Vice President Consultancy, Ramki Enviro Sustainability Limited, Hyderabad, for his keynote address on topic Solid Waste Management, Opportunities in CIE, Policy and Framework. We would like to thank Dr. Ashokan Pappu, Chief Scientist CSR MP Bhopal, Nodal as well as Coordinator CIE Waste to Wealth team, for his welcome address as well as the organization of this industry meet. Thanks are due to Dr. Manish Mudgal, Senior Principal Scientist CSR MP Bhopal, for moderating the session. Thanks to Devendra Singh, Principal Scientist TMD, CSR Ministry of Science and Technology, New Delhi, for his cooperation in organization of the event. When we come to the technical sessions, which is on alternative building materials and structures using silica-rich waste, first of all, in this, we would like to thank Dr. Indranil Chaturaj, Director CSR NML Jamshedpur, for his address and for chairing the session. Thanks are due to Dr. A.K. Sinha, Senior Principal Scientist CRRE Delhi, for presentation of technology on utilization of photogypsum for road construction. Thanks to Mr. Rohit B. Meshram, Senior Scientist NML Jamshedpur, for presentation of technology on quick repairing material by geopolymerization. We would like to thank Dr. K.N. Lakshmi Kandhan, Senior Scientist SCRC Chennai, for presentation of technology on tilite unit using thin precast concrete segment panels. We would like to thank Dr. P.S. Ambili, Principal Scientist SCRC Chennai, for presentation of technology on economical, eco-friendly geopolymer concrete blocks. Thanks to all industrial participants who have spared their valuable time for attending this iconic meeting. Thanks to media persons for giving wide publicity to this iconic meet. Last but not least, thanks to IT team for successful organization of the industry meet in virtual mode. Apart from this, we would like to thank all the audience who are attending this program, as well as thanks to all those who are directly or indirectly involved in successful organization of the meet. Thank you all.
I think.
Thank you.
Yeah, once again, I think now we are coming to the end of the day. Formally, before closing this today event, just wanted to. I believe you are able to hear me. Yeah, once again, very good evening to all of you. Formally, now we are coming to the completion of this today event. This session, iCEN-42, is going to be over. So before completing the concluding part, just wanted to convey to all the audience for your valuable time in participating in this event. And special thanks to all plenary speaker, keynote speaker, and guest speakers, director and technology presenters. I am sure there are many questions are clarified by the participants, and they have sent me some text message also. They wanted to have clarify some of the points, interact and contribute, and in the interest of the overall perspective of this session particularly. So maybe I can request them to email me during the panel discussion on 15th of July. You can participate. We will create a forum. 5 minutes you can speak on the aspect what you wanted to highlight. I believe there are many industries from MSME they are watching, and we request maybe next 2 and 3 programs, they are very important. Maybe you can connect to all your MSME cluster network, to all the industries to join this event, which will be really useful to transform the marketable technology which is already there in the CSIR system to take to the industry for the society and the benefit of the environment. So with this, I would like to sincerely thank the moderator and Dr. Manish Mutkal as well as Dr. Dipti Mishra and my all friends who are here and supporting this event to make it a very important, fruitful meeting. And we believe there will be certainly some fruitful outcome is expected. So with this, once again, I thank my director, Dr. Avanish Kumar Srivastava, as well as the team director of this civil engineering infrastructure, Dr. Anandavalli, for their constant support and encouragement in organizing this event. And special thanks to Ministry of Earth Science and Ministry of Science and Technology and our own friends from CSIR headquarters who are created this platform to share, interact, and benefit each other for the for contributing to achieve the Government of India goal on Clean India and Make in India programs. With this, formally we are closing this session. And before that, special thanks to Dr. Ashok Kumar also. He's a scientist, outstanding scientist head from Central Building Research Institute, who was monitoring since from the beginning of this event. And his intervention is going to make a major contribution to this program in the future coming programs. So with this, formally we are closing today. Thank you very much. Namaskar.
Thank you. Thank you very much.